In this video we'll have a look at finishing the mechanical side of the mill power feed and the final assembly. Let's do it. I'm making a shaft so I can mount a clutch and also a drive pulley in order to drive the power feed. To ensure this was concentric, I decided to turn between centres. To remove the boss off the pulley, I used the shaft I made earlier as a drive mandrel. I just pressure turn this between centres. Okay, time to make the bearing that goes in the end here. I use the digital readout bolt hole circle to easily put these 4 holes in. I put a bronze bush in this back bearing. If you remember back to my quick change gearbox build, I've got a surplus supply of these. I need 5 or so I went online and I ordered 5. Packs of 10. Whoops. I need a clutch in this power feed, so this is going to be a knob so I can engage and disengage the power feed. To make the flutes I could have used the digital readout for all of them, but I decided to use collet blocks for the most part because they're quick and easy. Now to transmit torque between this gear and the shaft, there's going to be a sliding dog clutch at the back here. So let's make that. I've got a video on how to design a dog clutch. Click the card if you want to see some simple ways of setting up the geometry. I didn't want this gear to shift on this shaft, so I carefully applied some super glue, making sure it didn't drip down into my collet. That would be bad. Moving on with the build now.
Get ready, Tom. Stickers coming your way.
So it's a sticker from Zonitzer. Got a sticker from Rustinox in Belgium. Check him out. Funny guy, good channel. If you've got stickers and you want to send them to me, contact me on this email address. And back to our scheduled content. As part of this project, I'm taking the opportunity to extend the travel on my mill table slightly. So this is going to be an extension for the trough at the end of my table. So this bowed a small amount while welding. It's nothing too severe. So perhaps it's a little bit overkill, but I'm just checking the mating alignment of these surfaces. This side I'm pretty happy with, except for around this weld where it's a little bit high. The lead screw is just going to butt up against this, so I don't really care about this one. The back bearing tap that I made earlier has a little bit of play in it. So right now I'm just adjusting it so my shaft runs parallel and true. And I got it right within about 1/100th of a millimetre. That's good enough. Okay, let's mount all this and see how it goes. Yeah, it's not quite there. This isn't rigid enough. Mechanically it's very complex, and nothing's constrained well enough. So here I'll just show you how the clutch works. This is a mashup of about 3 or 4 designs. The way it works, you can turn the control knob, and the brass pin set in the end is offset. And it drags the dog clutch backwards. The pin does create a fair bit of resistance on that dog clutch. I'm not happy with this. I'm looking at this arrangement and I can't help but think if I move this stepper here, I'll still need a clutch, and I think I'll make something quite small to go in here. So the assembly will grow by about this much. I think I can live with that. So I took all of my hard work and then I decided to dump it right in the mill so I could repurpose it. There's a T-nut slot in the front of the table here. My intention was always to use a couple of nuts in here and limit switches in order to drive the table. Now, I've mounted the DRO in those slots. I'm not going to use this T-nut slot. I'm going to make a new one that bolts onto the front of the DRO. So we've got T-nut slot, DRO, T-nut slot. And the stop for my limit switch is going to be built off this section of the digital readout as well. Now, there are other considerations. This lever here barely works with these scales as it is, so this handle will have to be extended out. Alright, got our stock. Plasma cutter wouldn't get through this, so I had to resort to the angle grinder. 0 out of 10, would not recommend. I was asking a lot of the setup here. I had the part clamped inside the vise and using 2 screw jacks. Turns out not good enough. So the approach I had wasn't rigid enough, so I'm going back to horizontal milling. I've got the steel pulled up hard against the vise and clamped down. This part is about twice the length of my table travel. I have to shift the part twice with each operation, using the vise as a straight edge. And of course clean before putting it back down. I then made the slot using a 3-flute roughing end mill. Now I'm going in with the T-slot cutter. The strange noise in here in the background is the CNC router. Multiple projects on the go, sorry. Chip evacuation seems to be a problem, so I've ordered 2 extra cutters just to be safe. So this time as I'm doing it, you can see I'm backing off a lot and clearing out the chips with a brush. And I got through the whole thing absolutely fine. Now I just need to make the T-nut sliders to go inside the T-slot. Let's now look at the X-axis lock for the mill. I need to lengthen this section in here. Now I could try and make an entirely new one of these. The problem is this spline on here. I could make this if I wanted to. That's a lot of work for what it is. So let's extend this. So I cut it off, drilled and tapped it, and that way I can screw a new thread into the spline head. Whoop. And a dab of Loctite just to make sure it doesn't come loose. Plenty of clearance now. Now I need to make the stop for the limit switches. All my screws are too long, so I'm using my lantern chuck to shorten these all accurately. And now to address the clutch design. There was much messing around trying to make springs. Nope. 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 Many designs were considered to stop the clutch slipping. And then, the answer. There's also some additional work to be done. This needs painting and the belt needs a guard, but I'm still undecided about painting the control box. Do I stay with the old school space age sci-fi look, or do I paint it green?